Dude, why am I being shot from above?
Because that's where the excellent connection.
Nice. 3, 2. Oh.
And by the way, you will not see the participants until they type something. So they gotta type something. So we'll be like, hey, in order to make sure that we see you, and in order to make sure that we know who's in the chat.
Isn't the participation the
It is
the discussion board thing?
But it's nice. It would be nice to just see how many people we get.
Yeah. Well, you can see viewers.
Yeah, but the viewers won't like us.
It'll tell us how many are in there.
Oh my god, it's lagging up big time.
Yeah, it should. Yeah, it should. Does it record who? No,
That I don't know.
no live.
Oh.
Do I need to go to videos?
Maybe we can turn it off so you can get
Ooh, live. Here we go.
That's so cool how you can just do that. It says excellent connection, but it's super terrible.
It doesn't look like I'm moving, does it?
Oh.
It's like really choppy.
Yeah,
Super duper choppy.
it just kind of froze. This is a
How
problem.
many seconds was that?
No idea.
Oh, okay.
You're still on your feed. You're still over there.
Now that's weird.
Oh,
This is super bad connection.
Charlie. Charlie, out of there, buddy. Go home. Is that better?
Move.
Yeah,
So
that's
it's better
much
on that one.
But I still didn't see it on the live lecture. Whoa, that was like 10 seconds. This is super duper slow.
It's just replaying.
I mean, we can switch it if you want to. I have to push out all the links and stuff to them and hope that they find it.
Is it slow on there? Is the question. Everything is so delayed. Oh my god, it's recording what he said a long time ago.
It's doing the hand thing.
But that's how it was the other day, too.
Oh, sorry.
Which Wi-Fi are you on? I'm on FTIS Wi-Fi.
FTIS Wi-Fi.
Okay.
I can get over there easily. Because of this.
Hey Charlie, do me a favor, bud. Why don't you sit down over there until we're ready for you?
Thank goodness you guys are off.
Well. Oh.
Because I would not be ready to teach today. No? Holy jeez. the home option of online learning
They
could not be worse.
right now too.
Oh, we're live.
You are.
Sweet.
Can you see that?
Mm-hmm.
Oh, that's much better now.
Yeah. Yeah.
How many people do we have currently?
Check.
Okay, we have our.
Do you have the other? Do you have the other mask?
I don't have my other mask, which is fine. I'll take this one off.
Yeah.
Are those all like messages of where do we go?
Wow. Hey, so fifth period is only his class.
No, my class.
Okay.
So me and him.
We're about 8 seconds behind here.
Yeah, 8 seconds isn't too bad.
And then here's the
So you want me to do this chat?
if you want to. It's like crooked.
Yeah, well, it picked up everything that about that opening of the can.
We know how sensitive.
Let me go ahead and check mine. We're starting, aren't we? 12:40.
It's up to you. Teach.
We got 23 watching right now.
23 watching. All right, guys. For those individuals that are watching, do me a favor in the chat. Go ahead and holler out your teacher. Either you are Mr. Wynn or Mr. Listerman.
Right now, Mr. Lishman's winning.
Big time.
The connection's much closer, or much quicker.
Yeah. Well, I think anytime you're doing live streaming, it bounces from like an excellent connection to a horrible connection to an excellent connection to a horrible connection. Damn. Oh, there's a win. You're in. You're in the game.
So right now we're waiting on everybody to join. So if you're wondering, well, when do we start? We're going to take about probably the first 5 or 10 minutes just to make sure that everyone has an opportunity to join. Right now we are at how many participants?
30.
30 participants. So we should see roughly around 40 individuals. So once we get close to that number, we'll go ahead and get started.
It's mostly Mr. Wynn's students.
So right now we're waiting on everybody to join. So if you're wondering, when do we start?
Is yours open?
First 5 or 10 minutes. Just make sure that
I have the
everyone has an opportunity to join. Right now we are at how many participants? 30 participants. See roughly around 40 individuals. So once we get close to that number, we'll go ahead and start. Hey guys, why don't you go ahead and give us an idea of whether you can see that screen or not. So that way we can adjust if we need to.
Is that better?
Is that better?
The
36.
screen is visible, so we're good.
Did you guys post the notes already or no?
I told them to post, I'll tell them to post my after the lecture.
That's what I'm going to do too. Alrighty guys, so let's go ahead and get started. Now, this PowerPoint is going to be available to you, so it's not really necessary to write down every single piece of information associated with this PowerPoint. What I would like you to do, in order to record your participation for today, I would like you to go ahead and take out a sheet of paper, something to write with, and you're going to write down some things as we go through this PowerPoint. Now, we want to make sure that this is interactive. So, make sure that you're participating. If you have any questions, please let us know because we have 3 awesome teachers here that are willing to answer your questions. We good? Okay. So what is science? Science is a method for being able to solve problems. And it is studying the natural world and coming up with a process to understanding these different types of phenomena that we see. So how did they do it back before science? If you were talking about hurricanes, because that's been on the news lately, Hurricane Laura, and essentially what we have is we have these hurricanes that are created by this energy that is in the ocean, and that energy ultimately builds up, and it builds up because of the warmness of the ocean. We know that through the process of science, but before then, a lot of people say, well, you know, it's the gods, it's Poseidon, it's these individuals that were able to control these natural phenomena, but now we know through investigation and through knowledge that it's actually the warmness of the oceans as well as the building up of that energy in the ocean. So science allows us to be able to answer those type of questions. Now this is a scientific method, and the scientific method is the scientific method is the investigational procedure that scientists use in order to go through and answer the problem step by step. So I'm going to give you an easy way to remember this, so you don't have to write any of this down. But I do want you to write down the easy way on how to remember the scientific method and the different steps of the scientific method. So here are the 6 steps of the scientific method. We have ask a question, research, gather information, hypothesis, experiment, analyze data, and drawing conclusions. This can also include discussion and talking with your peers about your results. So go ahead and write this down, and what you're going to notice is that the first letters of each one of these steps spells out our head. So I'm going to give you guys a minute or two to write down the different steps of the scientific method. You good? The first step is stating a problem or asking a question. So, Mr. Listerman, what's been going on these last 2 months?
There's been a virus. It's been out there.
Oh, yeah. Okay, that's still around, right? So the coronavirus is still around, and what you're going to notice is that we have people that agree or disagree about wearing a mask. What you're going to notice is that we have our nice anime figure here from Naruto. He's wearing a mask, and he's wearing it appropriately. So he's wearing it around his nose, and he's also wearing it around his mouth. Now, what you might notice is that
Kind of like this. Over the nose, over the mouth. That's how you want to wear that bad boy.
Now, what you might notice is that I'm not wearing a mask. And the reason why is because I am observing the 6-foot distance rule. So as long as you're 6 foot away from your from somebody else, you don't have to necessarily wear a mask. Okay? So, what's the problem here? That's the first question I want you to answer. So what is the question we have about masks and the coronavirus? So take about a minute to think about that and go ahead and write that down. What is the question about masks and the coronavirus?
Do we have? Do they have? That's what I was about to say.
Okay, now, if you are an individual whose last name is A through F, what I want you to do is I want you to put in chat what that question is going to be. Okay, so if your last name is A through F, I want you to participate just a little bit, and I want you to type in what that question would be. Mr. Ewald, can you do us a favor and read off one of those answers if you don't mind?
As soon as one pops up, I will surely read it off. You can probably go and I'll stop you if you want. Do you want to just keep going and I'll stop you when I get one? No, nobody has done it yet.
Do masks prevent the coronavirus?
Okay, so do masks prevent the coronavirus? That's an excellent question.
How effective are they?
That is also an excellent question as well.
Do masks work?
Do masks work? Absolutely. I think that that's important. Number one question to answer in terms of why we wear what we're wearing. Okay?
One more, Mr. Wynn, this is a really good one. Do they prevent, and why should everyone wear them?
Okay. Well, thank you very much for that, guys. Great job contributing. Now, the second step is going to be researching and gathering information. So we know a lot about viruses, and we know a lot about what could happen as a result of not putting in these different types of guidelines. So we have the Spanish flu of 1918, and we know that the Spanish flu had all these different peaks associated with the spread of the disease. So we know that, so we can use that kind of as a model to understanding what the coronavirus is. So your question number 2 is going to be, what are some resources that you could use in order to look up information? So we know that there's all sorts of information out there. What are some that we know that we can use in order to look up that information? So take about, let's take another minute and think about all those resources. Alrighty, so hopefully we got some resources in there. Let's say last names with G through M. Okay, so if you have a last name G through M, why don't you go ahead and provide us with one of those resources associated with looking up information. Now, Mr. Listerman, can you give us kind of some resources that you think are going to be reliable and going to be helpful for students?
Good one here. CDC website. Centers for Disease Control and Prevention. News articles. Encyclopedias.
Nice.
John Hopkins website.
Nice. Now, Mr. Ewald, I've heard of this really popular website. I think it's called Wikipedia. Okay, what do you think of Wikipedia? Is that a good resource?
When you think about finding resources for answering a question, so doing science, Wikipedia could be a starting point. So if you have a question and you're trying to go out and find some resources, Wikipedia would be a good place to start. That's not going to be your end-all, be-all. You're not going to find all of your information from Wikipedia. But Wikipedia is cited. There's some people that do some editing to make sure that the information on there is as correct as it possibly can be. So it would be a good starting point, but you're going to want to go out and look for journals or articles or websites or books, encyclopedias like people are mentioning on the chat. So those are the things that you're really going to want to rely on for information.
Absolutely. Now, a hypothesis is a possible explanation to a problem, and it works as a prediction to what you think what would happen in an experiment. So we're going to talk about an experiment later on, but what we have right now is we have Bill Nye. He's wearing a mask, and he has a candle here. What do you think? What is he trying to solve? What is he trying to hypothesize? So, what do you think, Mr. Ewald? What is he trying to hypothesize?
I think he probably posed the question of, if I wear a mask, will I be able to potentially blow out this candle? So is the mask going to be effective in stopping my breath from blowing out the candle? Could be.
Absolutely. And so with forming a hypothesis, it's very, very simple. Very, very easy to form a hypothesis. You would just simply say, I hypothesize that. And then what you think that prediction is going to be. So in this case, you only have two possible hypotheses. Either he will blow out the candle or he won't. Okay, so I hypothesize that Bill Nye will blow out the candle using that mask. All right. So question number 3, what is a possible hypothesis for testing the efficacy of masks and a candle test? So we have 4 different masks. We have the surgical mask, we have the mask that they gave us from KEA, we have a Fort Thomas mask, but unfortunately I took that home, so we're going to use and substitute this with a different mask. It's a cardinal mask, but it's the same type of mask. And we also have a gator mask, so ones that are really, really popular that we've seen, at least I've seen, a lot of people wear. So what do you think is going to happen? So what I would like you to do is write 4 different hypotheses on whether or not they're going to be able to blow out the candle. So I'm going to give you guys probably about 3 to 5 minutes on that one.
Mr. Wen, can you explain what efficacy means?
That's a great question. Okay, so efficacy simply means whether or not it will work. Okay, so how effective or how good will that mask work?
So it's 9 minutes so far. So like, perfect. Maybe more.
Alrighty guys, do me a favor. If you need more time, just let us know. And let us know that you need more time. Otherwise, we will move on.
Mr. Wen, would you be all right if we just did them one mask at a time and we asked for a yes or no answer
Great question.
on the chat?
So in this case, we will record the results later of what will happen due to the mask. But for now, what we're doing is we're creating a hypothesis. So a hypothesis is a fairly formal statement that you'll have to make. So all these different statements should start with, I hypothesize that. Now you can say mask number 1, mask number 2, mask number 3, or mask number 4, or you can be more specific if you'd like. Okay, so we're going to test this hypothesis or these hypotheses out performing an experiment. Okay, and so we're going to turn the camera.
There's Mr. Listerman.
Okay, and what we have here is a very, very simple test. So we have our candle, or we're just going to light our candle. Now, there is one condition that we forgot to mention. Mr. Listman, what was that condition that we forgot to mention?
Oh, if we do nothing,
So in other words,
no mask at all.
no mask at all. Okay, so we got to test this to make sure that Mr. Listerman or Mr. Ewald didn't like substitute a trick candle. I mean, that's a possibility with these two guys. Okay, now, so we're going to try this. What do you guys think? We're going to blow this out or not? We
You
should
got
be.
plenty of hot air, Mr. Wayne. I'm betting on you.
All right.
Okay, so does not having a mask, so uncovered, does that spread the coronavirus? What do you think, Mr. Listerman?
Uncovered does spread the coronavirus.
Now, we also know that the coronavirus spreads through water droplets from your mouth. And so that's one of the reasons why this test is so good, because we can determine whether or not water droplets are leaving our mouth using a mask. Okay, so we're going to do the first one now. Okay, number 1, surgical mask. Okay, go ahead and write in the chat what you guys think. Will this go out or not go out? You can just write a yes or a no in this instance. Yes or a no for this mask. We good?
Yeah, we're getting some
Get
answers.
some answers. We're 50-50 right now.
Ooh,
There we go.
little string of yeses.
Guys, love the participation. That's awesome.
We even got a yuh. Not sure what yuh means.
I believe that's a yes, sir.
That's a yes.
All right, so we're gonna give it a shot. Okay. So again, I'm not trying to bias the results in any way. I'm gonna blow as hard as I can in terms of trying to put out this candle. Okay. Sometimes I'll do it once or twice just to make sure that the results are verified. Ooh. Ooh. So you gotta watch the distance, okay? So watch the distance for that surgical mask. All right. So mask number 1, as long as you're not too close. Okay, mask number 2. What do you guys think? Okay, yes or no? Mask number 2.
See what we get.
Are we ready?
Got a whole lot of no's rolling.
Yeah,
in.
lots of no's
Lots
so far.
of no's. Oh, they have no faith. All right, here we go. So this is your fabric mask.
Oh.
I didn't even get a second breath in. All right, so this one would not be effective in terms of stopping the spread. Cardinals. Who likes Cardinals? University of Louisville.
Ew.
State bird. All right, so mask number 3. Now, this mask, I believe we bought from Finley Market, reputable source. They sewed it. Love the look, but is it effective? Okay, so yes or no? Mask number 3.
This one's got a few more yeses.
A few more yeses.
We're more along the lines of 50-50 on this one. Probably a little heavy no, but we got some yeses out there.
Uh-oh. Better go ask for my money back. Okay, here we go.
Any subscribers? So good.
Okay, so mask number 3. 2 hard breaths. and it stayed up. All right, so that's good. No, you can't blow it up. All right, so this is your Gator mask, and I don't know how many people wear the Gator mask.
It's a little hard to get on, much harder than the other ones.
It's fairly comfortable. I actually like this. I like how comfortable these are. Okay, so in terms of the Gator mask, mask number 4. Yay or nay? Yes or no?
Going back and forth, back and forth. Oh, couple no's.
You ready?
About 50-50 on this one, Mr. Wynn.
About 50-50? All right, I'm going to try to make sure that this is fairly comfortable. All right. And let's see.
Oh, no bueno.
So the Gator mask. Not all masks are created equally, so you got to be very, very careful about which mask to wear. Not only that, guys, but remember, we're professionals. Don't do this at home.
You're doing there, Mr. Wynn.
Alrighty, so what we just did was we performed an experiment to test all these different hypotheses, our different predictions associated with whether or not we thought our masks would work or not. Okay, and even if you're right or wrong, those answers are valuable and those hypotheses are valuable to be able to modify what we're going to do later on. Now, whenever we think about experiments, we have to consider variables. So variables are quantities that we can test for that have more than one value. So if we're talking about fertilizers and we're talking about plants, we might think of some variables that we're able to modify, like plant type, the amount of sunlight, the amount of water, room temperature, type of soil, and type of fertilizer. Okay, so we have to think about all these other variables as well. So a dependent variable. So a dependent variable is a variable that we measure or that we collect data on. So what you're going to notice from this chart is that we have all these different fertilizer types. Now these fertilizer types, A, B, C, and none, the way that we determine whether or not they have an effect is by measuring them. So this becomes our dependent variable. Now, data can be measured in different ways. So it can be qualitative data or quantitative data. So your qualitative data is your categorical data. So in other words, they could predict a type of color. It could predict whether something might happen. So in other words, it could be a simple yes or no. Whereas quantitative data is continuous data. So this is data that has preceding numbers or numbers that follow. So height, weight, and number of people in the room are all different examples of quantitative data. Now, Mr. Listerman, if we're talking about and going back to this experiment with masks, which one do you think this is? Is this qualitative data or quantitative data?
Well, since we didn't write any numbers down, and we were just yes or no answers, I would say that that would be qualitative data.
And you would be right, sir. Now, your independent variable is going to be the variable that affects the dependent variable, or it's the variable that physically changes, that we physically change. So in this case,
you can physically change the fertilizer type, and that's what we've done, A, B, C, and none. And notice that it doesn't stay the same. It's not consistent between these plants. Your constants and controls are going to be the variables that do not change. So you can see that the amount of sun is the same. So 6 hours per day for every single plant. Your amount of water is the same between every single one of the plants. And we can also say that all these plants are the same plant type. So these are all constants for constant variables. Okay, so what we just discussed was dependent variable, independent variable, constants, and then there's one more, and that's going to be your control. So your control variable is going to be the variable that doesn't get an independent variable. So in other words, it allows us to be able to compare it to all the other ones. So looking back at an experiment, Mr. Ewald, what was our control?
Our control was when you did not have a mask on and you attempted to blow out the candle. You weren't wearing a mask, so you didn't have your independent variable, the type of mask in there, and you used no mask and were able to blow the candle out.
So yeah, that's exactly what we see with this particular example as well. There's no fertilizer, and there's no fertilizer type in there, so we know that that's the one that we can compare number 4 to number 3, number 4 to number 2, and number 4 to number 1 to see whether or not fertilizer has an effect. Okay, so your question number 4. What is the dependent variable in our experiment? In other words, what did we measure? Okay, so take about 30 seconds to think about that and write that down.
Which, in our experiment?
With the masks.
Okay, so in our mask experiment. All right, so if your last name is an M through a Z, so M through a Z, I want you to tell me what you think the dependent variable is in the chat. Okay, so M through a Z, what is the dependent variable in the experiment that we conducted? We have responses.
Give it just a second.
Give it.
If the candles blew out or not is 1. Blows out.
Yeah, looking good so far. Lots of whether or not the candle could be blown out if the candle was blown out. So
Absolutely.
great responses.
Okay, so good job, guys, on terms of the dependent variable. What we were measuring was whether or not that candle went out. All right, question number 5, independent variable. So in other words, what did we physically change? So I'll give you guys about 30 seconds to think about that and write that down in your answers. Okay, if your last name is A through L, I want to hear your answers, or I want to see your answers. Okay, A through L. What was the independent variable? So in other words, what did we physically change? Okay, if your last name is A through L, I want to hear your answers, or I want to see your answers. Okay, A through L. What was the independent variable? So in other words, what did we physically change? Last name's A through L. I want to Okay, so what are some answers? If you won't mind, masks.
Mask, type of mask being used, the mask. Mask type. Type of mask.
Oh, you guys are doing a phenomenal job. Good job, guys. Okay, what was the control in our experiment? In other words, which one did not have the independent variables?
Who do you want to hear from?
L through Q.
All right, so L through Q, what was our answer? L through Q.
What's that? It'll come back on. It was really choppy, so.
You good,
Make that
guys?
sound good. We got feedback.
We good? Okay. Okay, so what is the constant in this experiment? So in other words, what didn't change throughout the experiment? So what didn't change throughout our experiment? Blowing out the candle. Now, there are several different answers that you can possibly give. So I want to hear from A through Z, the entire alphabet. What do you think are some constants in this experiment?
One is the candle, lighting the candle and trying to blow it out. The person blowing out the candle. The air being blown out of your mouth, the distance from mouth to candle, the amount of breath, the distance, amount of air, distance between the person and the candle, how hard you blow, who blows out the candle, the same person blew out the candle each time, the distance, candle itself, same candle, same person, strength of breath.
Awesome job, guys. Fantastic job. Okay, so again, in terms of the experiment, I think you guys understand the reason why only one person should have been blowing out of those masks. So it really does change the experiment if we have several different people doing the experiment. Now, you could have another experiment where Mr. Ewald did it or Mr. Listerman did it, but then they would have to be constants. So the next step is going to be analyzing data. So we want to make sure that we're able to convey the information, we're able to show our information in a way in which our audience understands it. So in this case, it could be in an easy-to-read table, a graph, or possibly even a chart as well. So you guys have heard of line graphs, you've heard of pie charts, so on and so forth. So those are the type of analyzing data that we want to be able to show to our audience. So I want you to create a chart as well. So you're going to create a chart showing the efficacy of the masks. So in other words, how well they worked. So you're going to list the type of mask and the results of the candle test. So remember that there were 4 masks, 1, 2, 3, 4. The first one was the surgical mask. The second one was the fabric mask. The third one was the cardinal mask. That was also a fabric mask, but it must have done something differently about this mask, probably the way it was sewn. And then the gator mask. So I'm going to give you guys probably 2 minutes in order to copy down the chart, record your answers.
All right, Mr. Nguyen, we have a little question about the difference between a control and a constant.
Excellent.
A control, student looked it up, said a control is things that can change but don't. Constants are things that can't change. Can you go into a little bit more detail about that in terms of a science experiment, not so much a definition from the dictionary?
Gotcha. So in this case, whenever we're talking about constants and controls, so just like the fertilizer experiment, we need to make sure that the fertilizer works to begin with. Because you can buy a fertilizer that just is terrible. You might as well not use fertilizer at all. So in this case, not having the fertilizer and having a fertilizer, that non-fertilizer acts as a control. Now, you could adjust the amount of fertilizer that you give to each one of the plants, but then that adds a different element to the experiment. So we want to make sure that if we're just testing whether or not that fertilizer works, we keep the same amount of fertilizer. Another thing to think about, let's say, for instance, you guys, I'm sure, are interested in buying cars. So you wanted to test whether or not certain sports cars were fast. So a control wouldn't necessarily be a sports car. You would choose a different car besides a sports car. But your constant could be the type of fuel that you put in each one of those cars. So you want to make sure that fuel alone wasn't causing a difference in performance. So hopefully that clears it up. If it doesn't clear it up, please let me know. I can think of all different types of examples.
So somebody asked, what does the right side of the chart say?
Results of the candle test. Okay, so sorry about that. It's results of the candle test. Okay, so then drawing conclusions. So you go back and you look at your original hypothesis. Remember where we wrote all those different hypotheses down? I hypothesized that and what you predict that particular mask would do. So we're going to go back and we're going to look and see whether or not we were correct or not correct. That's really helpful for us scientists because then we can modify future experiments by looking at that. So, question number 9, was your original hypothesis supported? So you're going to review each hypothesis and you're going to write either a yes or a no. So in this instance, this example, my original hypothesis was or was not supported. The mask was or was not able to blow out the candle. And again, guys, it's okay if your original hypothesis was not correct. Okay, that's okay. You're not going to get deducted points for not predicting correctly. So as you're finishing up those questions, you want to make sure to turn in those questions by the end of your class period. So that's going to vary based off of your teacher. I know for me, once we're done with this, I'm going to have a Schoology assignment up so that all you have to do is just take a picture of it, upload it to Schoology. Next, you're going to check and see whether or not your teacher has assigned any more work. Okay, so I'm going to assign work for today that's due on Thursday. That way you'll have plenty of time to get it done, ask questions, so that for the next time, your next time-bound event will be a small group or it will be individual. So I know that for Schoology, I have posted my small groups. If I have not put you in a small group, please let me know, because I want to make sure that everyone has a group to be able to collaborate with. Okay, so again, guys, make sure to check in with your teachers, make sure that you turn in this assignment, and make sure that you know about your next time-bound event. You know, so if you have any questions, please let us know. Thank you, guys.
Let me do this.
Give it 10 seconds or so.